Hello friends, my name is Hemant Jadhav, Department of Electrical and Electronics Engineering, ICEEM Engineering and MBA College, Aurangabad. In this session, we are going to have the review of your first elective subject, that is Electronic Devices and Circuits, EDC. Okay, so I welcome you all to this channel, Technotainment Hub. So let us start with the subject review. So at the end of this session, you will be able to understand these different points. That means there will be an introduction to this subject, electronic devices and circuits. The second point we are going to discuss here will be the importance of this subject and chapter wise review of this elective subject. Then we will understand basic concepts under this electronic, and we will also discuss on the question paper pattern. Okay, so let us move further. As you know that there are 5 subjects: engineering mathematics 3, EM3, then transformers and DC machines, electrical measuring techniques, then electrical power generation, that is EPG and its economics, and there will be an elective subject 1. Okay, so as an elective we have selected EDC subject to support the electrical engineering. The knowledge of electronics is also important, equally important. So nowadays interdisciplinary approach is very important. You should know the basic concept of all the branches along with your core branch. As electrical is your core branch, you should be able to understand the concepts, various fundamentals of electronics as well as mechanical as well as computer also. There and then it will be beneficial in your career path to go forward and to be successful in your career. Okay, so interdisciplinary approach is very important, and electronics is the supportive subject to electrical engineering. That's why we have selected this subject as your elective. Okay, so there are 5 subjects. 80-20 is the pattern of question papers, 20 marks for class test and 80 marks for the theory exam. As you know that out of 80 marks, minimum passing requirement in theory exams is 28 marks, and in class test it is 12 marks. So 12 plus 28, it is equal to 40 marks minimum required for passing. Okay, so but we will not think about the passing, we will think about the scoring that subject, because all the subjects of your this semester, first semester, these are very basic subjects and scoring subjects. So all the students of ICEEM second year electrical and electronics engineering, they will try to score in each and every subject. They will not think for the just passing, and they will understand the concepts of all these subjects. They will not think exam point of view. Okay, so I am sure about that. So as you might have understood the exam question paper pattern, so let us move further. So what is the exactly the contents of this subject, electronic devices and circuits? As you can see here, there are totally 6 chapters. First chapter is related with the basic circuits of electronics. Okay, so before directly starting to all these circuits like rectifier, filters and regulators, okay, before directly starting, we will understand some basic of electronics. We will understand some basic fundamental components of electronics. You might be knowing all these things, but we will just revise it in this video. And from the second video, we are directly discussing on these circuits. Okay, so what are the contents of first chapters? You can see here: rectifiers, their types; filters, their types; different terminologies associated with these circuits. Okay, so before being directly switching to these topics, you should be aware of what are basic components. Okay, what are the fundamentals of electronics? As you know that there are basically 2 types of electronic components. Okay, electronics can be divided into basically 4 categories: electronic components, measuring equipments, electronic materials and circuits. Okay, so in the next slide we are going to discuss on this, but basically there are 2 types of components: active components and passive components. Active means the components which are able to process the signals, which are able to modify the signals, which are able to reshape the signals. Okay, you know that basically there are 2 types of signals: AC signals and DC signal. AC and DC, these 2 are the types of, basically two types of signals. The components which are able to reshape or modify or process the signals by themselves, they are called as active components. And the components which are not able to process, not able to reshape or not able to modify the signals, मतलब जो AC का DC में नहीं कर सकता है, such type of components are called as passive components. So there are only three components which are called as passive components, R, L and C, means resistor, inductor and capacitor. Okay, these three are basically the passive components which are not able to process, not able to modify or reshape the signals. That's why they are called as passive components. Okay, you might be understanding this. And transformer is basically an inductor. There is a primary coil, secondary coil. That's why it is basically an inductor. Okay, that's why it is also passive component. Okay, and then what are the active components? The components which are able to reshape or process or modify the signals. Okay, like all semiconductor devices, means diode, transistor, FET, MOSFET, then dioc, triac, SCR, etc., etc. All these semiconductor devices, they are active components. Okay, so we are going to discuss all these things in the coming slides. The circuits or applications of all these active and passive components is included in your first chapter. In the second chapter, you can see the contents of second chapter. It is related with the transistors and its applications. How BJT it works, how is the construction of bipolar junction transistor, and how is the working of BJT. Second and third chapters are based on the working, construction, working and application of transistors. Okay, how the transistors are classified, like bipolar junction transistor, unipolar junction transistor, BJT, UJT, then FET and MOSFET. FET stands for field effect transistor and MOSFET stands for metal oxide semiconductor field effect transistor. Okay, so if you see the unit number 2, 3 and 4, these first 4 units are related with the working principle, construction, characteristics, biasing and applications of semiconductor devices. Okay, first chapter there will be applications of diode. Okay, so diode can be used as a switch and as a rectifier, you know that, you might have studied in diploma also. Okay, and other components like BJT, FET and MOSFET. What is the application of these three components? Application of these three major, there are three applications. Number one is it is used as a switch. Okay, BJT, FET, MOSFET तीनों का same application है, it is used as a switch. Then second application, it is used as an amplifier, and third one, it is used as in oscillators. Okay, switch, amplifier and oscillator, these three are the applications of BJT, FET and MOSFET. Okay, how to use these three devices as a switch, as an amplifier and as an oscillator, that we are going to study in chapter number 2, 3 and 4. Okay, section A will consisting of 3 chapters and section B will be consisting of chapter number 4, 5 and 6. Okay, there are two sections, section A and B. First 3 chapters will be in section A, second, third chapters will be in section B. Okay, now as far as unit number 5 is concerned, you can see here the transistor model, hybrid parameters. Okay, then after discussing the applications of all these devices, how to do the AC and DC analysis or mathematical analysis of these circuits, that we are going to study in chapter number 5 with different types of models. These models are presented by different scientists, to study their analysis, to study their mathematical and experimental analysis. They have proposed some model. Okay, so hybrid models or hybrid parameters we are going to discuss in chapter number 5, and chapter number 6 we are going to discuss on frequency response or high frequency and low frequency equivalent circuits of these devices, of these different circuits which are based on BJT, FET and MOSFETs. Okay, so if you see all these 6 chapters, all these are having the study of active components. Okay, Basically, you should understand what are active and passive components first of all. Then what are the applications, how is the construction, how they behave, what are their characteristics, and what are their applications. Okay, that we are going to discuss in this subject. This subject is very interesting and very much important as far as an electrical and electronics engineer point of view. This will be very beneficial in your engineering career. So let us come to the next basic concepts. Okay, so here you can see this diagram. You should know what is voltage, current, and resistance. Okay, so here you can see the diagram in which water is flowing through the pipe. In first diagram, there is the flow of water is with low pressure. Okay, in second diagram, flow of water is with high pressure, and in the third diagram, the large diameter of pipe, due to which the large amount of water is flowing through the pipe. Okay, so correlating these three diagrams with our three terminologies like uh, current, voltage, and resistance. Okay, so water flowing through this pipe is like flow of electrons through the wire. Okay, so flow of water is equivalent to flow of current, right? So how can we define the current? Current is nothing but the flow of electrons. You know that flow of electron. What is an electron? Electron is the smallest particle of an atom. Other particles are protons and neutrons. Okay, so flow of water through the pipe is like flow of electrons through the wire. That's why which is water is equivalent to flow of current. Okay, flow of water is equivalent to flow of current. Second, we can see what is voltage. Voltage can be defined as the potential difference between 2 points, potential difference between two levels whose mechanical equivalent is pressure or force. That means if you increase the force or pressure, the flow of water will increase. In the same way, if you increase the voltage, the flow of current will increase. V is directly proportional to I. That is the basic Ohm's law. V is equal to IR. If resistance is constant, voltage is proportional to current. Okay, you know that the basic Ohm's law. Okay, and friction, that means opposition to the flow of water. Friction of inner surface of pipe, which is opposing to the flow of water, that means which is equivalent to the resistance. What is the definition of resistance? It is opposition to the flow of current. Similarly, its mechanical equivalent is friction. Okay, so from this diagram, if you correlate this three concepts using these three diagrams, like water is equivalent to current, water flow is equivalent to current flow, pressure is equivalent to voltage, and friction is equivalent to resistance. Okay, what is current? Flow of electrons. What is voltage? Potential difference between two levels. What is resistance? Opposition to the flow of current. Okay, you should understand the basic difference between voltage, current, and resistance. Now, as I told you, the basic electronics can be divided into four categories: components and devices. Second, measuring instruments. First, component and devices, measuring instruments, materials, and circuits. Okay, so as far as components are concerned, electronic components can be divided into two categories, as I told you: passive and active. Passive components, there are three components, only three components: resistor, capacitor, and inductor. Transformer, it is basically an inductor. That's why it comes under the passive list of passive components. Okay, R, L, C, and transformer. These three are, keep in mind, these three are the passive components. Why they are called as passive? Because they cannot change they cannot reshape the signal, they cannot modify the signal, they cannot process the signals by themselves. That's why they are called as passive components. Okay, other category is active: diodes, transistors, operational amplifiers, FET, MOSFET, SCR, diac, track. All these semiconductor devices, they are called as active components. Why? Because they are able to reshape, they are able to modify, they are able to process the signals. That's why they are called as active components. Okay, so this we are going to discuss later on, then in detail later on. Then second category is what is measuring instruments. Okay, so if you see, measuring instruments are nothing but various measuring equipments or measuring instruments you might have used, like digital multimeter. Multi means many, meter means measurement. Okay, which measure different electrical and physical quantities. Electrical quantities like voltage, current, frequency, this can be measured by using multimeter. Physical quantities like temperature, pressure, etc., this can be measured by using by using that meter. That's why it is called as a multimeter. Power supply, you know, the without the use of power supply, it is not possible to run any or to make on any electrical or electronic equipment. Okay, voltage and current sources are nothing but the sources of providing the voltage and current. Okay, these are the equipment. Oscilloscope is the equipment which is basically called as CRO, cathode ray oscilloscope. You might have used this equipment to see the outputs of different circuits, or to see the output of to observe the waveforms, AC or DC waveforms of different circuits. Okay, CRO, cathode ray oscilloscope. Then function generator, its name implies that it generates something. What it generates? It generates sine wave, square wave, triangular wave, such type of waveforms. Okay, as the waveforms which are required to give, if some circuit required to some inputs, like sine wave input is required by some circuits to for the testing purpose, then that particular sine wave is generated by function generator. Okay, so function generator is an instrument, or is an equipment which generates different types of waveforms like sine wave, square wave, triangular wave. Okay, this is the second category. Third one, materials, electronic materials. Basically, there are three electronic material: conductors, insulators, and semiconductors. Okay, all of you are aware of this. What are these components? You know the basic concepts of all these components. Conductors are good conductor of electricity. That means current flows through them. All metals are conductors. Insulators, they are bad conductor of electricity, like rubber, wood, glass. Electricity or current cannot flow through these materials. That's why they are called as insulators. And third category, semiconductors, the materials which are able to which shows the properties of both type of materials, like conductors as well as insulators. Their properties lies between conductors and insulators. That means they can act as an insulator as well as a conductor as per our requirement. Okay, you know that semiconductors can be further classified as intrinsic semiconductor and extrinsic semiconductor. Okay, intrinsic means pure and extrinsic means impure. Impure means the semiconductors obtained after doping. What is doping? Doping is the process in which impurity is added in the pure semiconductor. Okay, impurities are added in the pure semiconductor. Addition of impurity in pure semiconductor, it is called as doping process. After doping, you will get the extrinsic semiconductor. An extrinsic semiconductor can be used as a conductor, whereas intrinsic semiconductor can be used as an insulator. Okay, these three are the basic types of materials. And fourth one category is circuits. So we are going to discuss various circuits in our syllabus. Okay, rectifiers, amplifiers, oscillators, filters, regulator, attenuators, etc., etc. Rectifier is the circuit which converts AC to DC. Amplifier is the circuit which, here you can see, rectifier which converts AC to DC. Amplifier is the circuit which converts low strength signal into high strength signal. Okay, low input to high output. Oscillator is the circuit which generates oscillations. Oscillations may be sine wave, triangular wave, square wave, whatever it may be, which generates the oscillations, which generates the waveforms. That is called as an oscillator. Filter, which is nothing but electronic filter, so which removes the unwanted portion of signal from the wanted signal. Okay, just like water filter, which filters the impurities from water and purifies the water. Similar case is here. The electronic filter will purify the signal after removing the unwanted signals like noise, etc., etc. Okay, so these many signals we are going to discuss, these many circuits we are going to discuss in this curriculum of EDC. So here you can see these subjects can be divided into four categories: components, measuring instruments, materials, and circuits. Okay, one by one we'll discuss each and every part. Now what you are going to see in this slide, as I told you, there are basically three passive components: resistors, inductors, and capacitors. Okay, resistor, capacitor, inductor, these three are basically three passive components. Passive क्यों कहा जाता है? Because they are not able to modify, process, or reshape the signals. What are their units? Ohm, farad, and Henry. Ohm, kilo ohm, mega ohm is the unit of resistor. Capacitor, farad, microfarad, nanofarad, picofarad, unit of capacitor. And inductor, Henry, millihenry. These are the this is the unit of inductor. Okay, every component can be classified as fixed and variable. You can see the symbols of fixed and variable resistor, then fixed and variable capacitor, and fixed and variable inductor. Okay, you can differentiate the symbol. Then you can see how they are physically looking like. Inductor, resistor, and capacitors are looking like this. Okay, resistors are having color codes, color bands on its body. Then variable resistor, uh, like this, having trim pot, they are called as trim pot. Then potentiometer pot and preset. Okay, these three are variable resistors. Then if you see other second component, capacitors, various types are there, like polyester capacitor, disc capacitor, and electrolytic capacitor. The electrolytic capacitor is cylinder type, having the polarity. Polarity means plus and minus. Okay, we have to check the polarity of this capacitor, electrolytic capacitor, before using it for any circuit. And other two types, like polyester capacitor and disc capacitor, these two are not having the polarity, that means not having the plus and minus terminals. You can use it, you can connect it without checking its polarity. No polarity to these two types of capacitors. Okay, and other one is this variable capacitor, which is also called as gang capacitor. If you see the inductors, there are three types: ferrite core, air core, and iron core. Okay, based on the what type of material is used for as a core. Okay, if the core material is ferrite, it is called as ferrite core. Inductor is not just a coil, okay, wound on the core. And if the core material is ferrite, it will be called as ferrite core. If the core material is iron, will be called as iron core inductor. And if there is no core, air is acting like a core, it will be called as just a winding of wire. Second one, it is called as air core inductor. Okay, so you can see on the last column, in the last column, the applications of these components. Okay, so as you know that application of resistance is opposition to the flow of current. That's why its application is current limiting. You know, the application of capacitor is charge storage. It store the charge and release whenever required. Okay, that's why it is used in filters. Why? It allows AC and blocks. DC, that's why it is used in filters. Similarly, exactly opposite of that, the third component is filter, which opposes change in current. Inductance opposes change in current, which is used, inductor is used in filter circuit. Okay, why? Because it opposes the change in current, and it behaves exactly opposite as that of capacitor. That means if capacitor allows AC and block DC, inductor will allow DC and block AC. Okay, so capacitors and inductors both are used in filter circuits. Resistor is also used in filter circuit, but its basic use is current limiting. Wherever there is requirement of current limiting or current protection, there we can use the resistor. Okay, now let us move to the next slide. Here you can see the active components. First active component is diode. Okay, and there are many types of diodes. Basically, first type is a PN junction diode. That is important for us. You can see the symbol of PN junction diode, how physically it looks like, and what is its application. Okay, so basically a PN junction diode is a two terminal device which is used, a two terminal semiconductor unijunction unidirectional device. Okay, I'll repeat once again. A PN junction diode is a two terminal. Which are these two terminal? Anode and cathode are the two terminals. So PN junction diode is basically a two terminal unijunction. Unijunction means having one junction only, PN junction. Unidirectional means current flows in only one direction. And semiconductor means it is made up of semiconductor material, okay, which is used as a switch and rectifier. A PN junction diode is a two terminal unijunction unidirectional semiconductor electronic device which is used as a switch and rectifier. That is the basic definition of a PN junction diode. There are different types of diode like Zener diode, LED means light emitting diode, photodiode, tunnel diode, Schottky diode, etc, etc. Okay, so just for the purpose of knowledge I have shown you all these types, but as far as your syllabus is concerned, only PN junction diode is there in your syllabus. Okay, now let us move to the next slide. Other active devices are BJT, means bipolar junction transistor. BJT, three types are there: PNP, NPN and photodiode. Okay, PNP means two P type materials and one N type. NPN means two N type materials and one PNP, and you can see their symbols also: NPN, PNP and phototransistor. You should be able to identify the component from its physical appearance. Next one is UJT, unijunction transistor, and its symbol. Field effect transistor, there are two types, N channel and P channel, and its symbol. And next, last one is metal oxide semiconductor field effect transistor, that means MOSFET. Basically there are two types, enhancement type and depletion type. Okay, and these two are further classified as N channel enhancement, P channel enhancement. Similarly, N channel depletion and P channel depletion type MOSFETs. Okay, metal oxide semiconductor field effect transistor. Here you can see their symbol also. Okay, now if you see the applications of all these devices, all these transistors, you might see that as an amplifier and as a switch. Okay, this is the common application for all types of transistors: BJT, FET and MOSFETs, switch and amplifier. This is the basic application of all these devices. Okay, and as far as UJT is concerned, it is used as an oscillator. Okay, if anyone asks you what is the application of BJT, FET and MOSFET, you should be able to tell him that basically there are three applications: switch, amplifier and oscillator. Okay, I'll repeat: switch, amplifier, oscillator, BJT, FET and MOSFET, application of these three. Okay, now let us move to the next slide. As I told you, the next category after the components is electronic materials. Okay, the materials which are used to fabricate, to manufacture the components, electronic components. Okay, the materials which is included in the subject of electronics, basically there are three materials: conductors, insulators and semiconductors. As I told you, conductors are the good conductor of electricity. Good conductor of electricity means what? Their resistance is very low, having low resistance, that's why current flow is more. Okay, because you know that resistance and current, these two are inversely proportional by Ohm's law. V is equal to IR. So as resistance is very low, current will be high. So good conductor of electricity. Which are the materials? Which are the examples? The examples are all metals. All metals are good conductors. Then second category is insulators. Insulators, they are having very high resistance. So as you know that wherever there is high resistance, current flow is very low. Okay, if infinite resistance will be there, current flow will be zero. Practically it is not possible. This may be ideal condition, but practically zero current flow is not possible. every component will be having some resistance, and every electronic material will be having some resistance. So insulators are the bad conductor of electricity. Okay, what are the examples? The examples of wood, glass, rubber, etc. Third category is semiconductors. Okay, so what are the semiconductors? Semi means half. Okay, they can act as a conductor or they can act as an insulator. They can allow or they can suppress the electrical current flow. Okay, that means as per our requirement we can use them as a conductor or as an insulator. As I already told you, semiconductors can be further classified as intrinsic semiconductor and extrinsic semiconductor. Intrinsic means pure form and extrinsic means impure form. When they become impure, when we add the impurity in pure semiconductor, and that addition of impurity is called as, that process is called as doping. After doping, the semiconductor material becomes extrinsic semiconductor, and then we can use it as a conductor. Okay, now moving to the next one. As far as this video is concerned, we will stop here, and from the next video or next session we will discuss from the electronic material. We'll start again from the electronic material, and then one by one we'll discuss on each and every component and circuit, active component and its application, the circuits based on its applications. Okay, so till then, goodbye. Have a nice learning. Okay, we'll stop here. Thank you.